All right, Theta exercise 103. We're going to have a shot at doing question 2. Now, question 2 is asking about diagrams, and each diagram has a line. And the idea is you're to find the gradient of the line. So in this case, question 2a, has a line that looks like this. Now, this is not very well drawn. This is a 3, and this point here is 5. So obviously not drawn to scale. Okay, so x and y. Now, the idea here is you can choose multiple different ways to do this. Perhaps the most intuitive way, which I enjoy, is just to say, well, how many units up has the line traveled, and how many units across has the line traveled? So if it's just crossing the x and y axis like this, and we're looking in relation to the origin here, we can see it's traveled 3 units up and it's traveled 5 units along. So the gradient is going to be rise over run. That's going to be our m value. And rise is 3. And the run is 5. Now there's one more component to this, and that's to ask the question, is it a positive or negative graph? Now a positive graph is always top right to bottom left. It always travels in that direction. This is a positive graph. A negative graph, of course, is going the other way, and this graph is such a graph. So it's negative graph, so therefore this is going to be negative 3 over 5. All right, another way of doing this is to actually look at these points not just as where intercepts, as in terms of where they're crossing the x and y graph, but actually give them coordinates. So this one here, for example, is going to be 5 along, 0 up. This one here is going to be 0 along, 3 up. Then we can use the gradient equation. We can say m is equal to y2 minus y1 over x2 minus x1. So we've got y2, well, I'm just going to call this x1 and y1, and this x2 and y2. So we've got y2, which is 0, minus y1, which is 3, over x2, which is 5, minus x1, which is 0. And 0 minus 3 is minus 3 on 5. And there is our gradient. Now, normally, of course, when you do this, you ask the question, well, could I simplify this? In this case, we can't, so that is the gradient.